Hello there and welcome back to Tripplikit and part 6 of our investigation into designing, developing and building cheap triplicate priced PCBs. So the last time, in the last video, we had some PCBs and we had a bunch of bits. So in this video I'm going to solder the bits onto the PCB, and if we get time we'll test the PCB. Now normally I edit these videos quite hard so you don't have sort of endless minutes of me hunting round for whatever tool or looking at a screen going but this one I thought I'd fire the camera up, fire the soldering iron up, and we'd try and solder it together real time. And I also have another innovation, which is I've got my tablet up here on a music stand to give a wide angle, and the trusty Sony will be as usual pointed down in reasonable close-up as what I'm doing. So without further ado, shall we get set up and get stuck in? Okay, so tell me in business, we've got the anti-static mat out and we have, pull that off the printer, a list of parts. So should we put some components down? I guess we start with some resistors. $82K. Right, so 82Ks are R1 So the resistors are slightly too big for the footprints. Let's see if we can add a little persuasion. And the other 82K is DIY ruler. R4. Oh well, she'll do. Right. 82K done. 330 ohms. These, I believe, are 12, 13 and 14, they're the LED series resistors. Okay, that's those done. Finished with pile. What have we got here? A relay. More resistors. These are 22k. Which are R11. Seemingly is our only 22k. R11. And where is jolly old R11 there? That's the base resistor for the relay drive transistor. Right. Resistors. These are resistors. Right, these are $2K2. Of which that is the only one. There's my ruler. R10. R10. Oh no. So, any more resistors? What's in there? Oh, pin headers, transistor, diode, that's a resistor. These are 1K. Again, that is this one. Which is R9. R9. Come on. $10K. See, they've supplied these in anti-static bags. Which seems a little silly, really. Right, big bunch of 10Ks, starting with R2 and R3. Wire's broken. Man. And R3. Any more 10Ks? R5 and R6. Oops. Crossed over. Yeah, that's the end, just the 4. Come on, back in you go. So, any more resistors? I don't think there should be. Let's do that. There's some more resistors. 47 Ks, which are this guy, I think only 7. And a big resistor, which I'll wait for now. Right, let's solder them on. Normally I'd work under the magnifier, but if I'm using this it blocks the camera, so I'm going to avoid using it if at all possible. And I did get the solder out. Spring. Sprung. So far so good. Shall we see if we can zoom her in a touch? And hopefully I'll manage to stay in shot. So, I would like to be entertaining you with a witty commentary at this point, but I find I can't solder and talk at the same time. I am no good at multitasking. Come on. That us, are we done? Get a bit of that blob off that one. Right, so I have decided, although I'm going to try and do this real time, I'm going to stop the camera every so often so I don't lose too much if something has happened horrible with the technology. So I'm going to stop and restart there, and I may actually go to lunch as well. Right, so I have had some lunch. It was very nice, thank you. So we'll turn the iron back on. So next I am going to put on the big resistor, the current sense resistor. So I have to find it amongst all my bits and pieces here. Ah, there we go. And just check. Let's double check. It's a pain to get out again. Yeah, alright. 1 ohm. Trouble is, the more I zoom in this camera, the better you can see what I'm doing, and the easier it is for me to get out of shot. Hopefully we have a decent compromise, and something's gone on the floor. Alright, so now we're going to put some capacitors in. We put in, well, I suppose conventionally you start with resistors and capacitors and then go on to semiconductors. Tend to work upwards because it is easier to put say resistors in without having connectors and capacitors sticking up. Does that make sense? Probably not. Anyway, it's what I do. So I need the little bag of capacitors now. LEDs, what's that? MOSFET, empty. That could be a worry. Transistors, diodes, etc, etc. Diodes. It's a worry. What have we got here? A heat sink. Don't know what that is. What's that? No, more LEDs. Unfortunately, oh no, hang on, there was a bag fell on the floor. Give me a minute. Which just happened to be our little 0.1 microfarad capacitors. And we have how many of those? C1 to 6. No, apart from C2. C1 and C3 to 6. Are we in the camera? C1R. And I do not know what's upset Minnie now. C4. So I've got 1, 4 and 5, 6, 3 is, and we're still in shot. This one, five little capacitors. So, a bit more light on the job. See if we can get these soldered in. Say, the soldering iron bit has seen better days. I'm sure I have another one somewhere. Oops. But God knows where. There we go. That's the lot. No, apart from that one. That one's sitting up a bit. Come on. That looks good. So we'll get these to the side cutters. A bit more of that. Sure, you're not supposed to fire all the bits of wire all over the room, like I do, but there you go. What else have we got in the way of capacitors? Where are my... we've got the 100 microfarad, and that's it. So somewhere I should have 100 microfarad electrolytic. haven't seen one. I might have to go into the box. Excuse me for my back. There we go, 100 microfarad capacitor. All my various projects live in those. Second-hand cardboard boxes and the filing system. Right. I'm guessing that bit is. I guess if, come on you go. I've lost my solder now. We're in here. Starting to regret buying a green anti-static mat. Getting a circuit board with green resist on it. It was hard to see. Camouflaged, huh? Oh, how did that happen? So, what now? What now? I guess we could have a go at some diodes. So let's have a look for some 1N4001s. Diode standard. 40 amp, I think that's the generic. First bag I picked up as well. However, we can 1458986. 1458986. Those are the ones, so we got 3 of these. Let's get rid of these capacitors. Done with them. Right. We want D1 and D2, which are D1 is there. Come on. D2 is down there. Yeah. Oh, come on, stay in the picture. And what was the other one? D5. Right way around. Yeah. Right. Grab the iron. Alright, I think I will just pause the video there. Well, not pause the video, just stop it and restart it. So, if you are vaguely interested in how I run two cameras and synchronise them, that's it. I just synchronise those noises, because you can only synchronise it to one frame, 30 frames a second, so it can't be that accurate. So anyway, moving on, diodes. What are these? Schottky rectifiers. Okay. What's that? 4001, I believe. I'm going to put that there. Find out at the end. Diodes, there we go. SR140, D3. D3, I'll check the number again, ends in 408. Yeah. Okay, so D3. I had some parts left over from building the strip board version, which is why the packet's already opened, and that is D3, which is going to be there. Some spare ones if I break it. And the Zener, which is 1N523, whatever. Should we try over that one? There we go. Zener. Which is D4. Yeah, goes across that pot. Whoops. Right, we'll get those. Oh, turn the iron off. In an attempt to make the bit last a bit longer. Last a bit longer. That's it. End up talking to yourself. To say, I always talk to myself, but now I have an excuse. So, oh yes, making a YouTube video. There we go. Some radiator turning on or off. So what now? we've got 2 transistors, and then we're into things like the relay. Right. So let's put the... oh, there's the LEDs of course as well. Right, well we'll do that. And the trim pots there. We'll do this. No, we won't. We will do this. Come on. So, put 1 pin in, yeah, it's still in the camera on an angle, so remount that there. There we go. That is now flat down, so we can solder the other 2 in. Alright. Should we put these LEDs on and the relay? Yes. Come on. Get out of there. No. Nope, that is the wrong way around. Get the flat on the LED against the flat on the ident. There we go. To do the angle. You should be able to see that okay. I'm looking at the tiny little screen on the camera, which is not telling me. Right. Green LED. I need to cut this one. Green LED. And red LED. There's some red LEDs. The bag is already open. There we go. So, competition, see how far we can fire them. Alright. So we will try the relay drive transistor, which is what this is. BC548, I believe. 547. Nearly. Oh, come on, stay in shot. That looks good. I will take a magnifier and check over the whole thing when I'm done. I probably won't film that. Okay. What should we do now? The relay. Let's get rid of these. What happened to the relay? There's the relay. Don't need that bag anymore. Again. Wire strippers. Why I got the wire strippers out? Well, I do know why I got the wire strippers out. Support the end of the circuit board. Somewhere I have a thing which sort of holds the board and you can turn it over. See what I mean? I don't know where it is. Right. Yep. That's off at a funny angle. There we go. That's down flat, so we'll get the that's the relay. Leave all these connectors till last. And the USB interface and the SD card interface I'm going to leave till I've tested the rest, because if something's wrong and they're putting 12 volts onto one of these connectors, and there's no point blowing them up. That's what I'm saying. Better check first that they're connected correctly, or the supplies are anyway, at least. I'm rambling now because I'm trying to think what I'm doing and talk. Okay. Those wires are a bit big. Rubbish. So now I guess we're on to the main transistor, the power transistor. I can't really pin this. If these are transistors, we'll find out. No, what's that? Which goes over the text. Oh. Well, anyway, we need to get the heatsink on first. Ah. I thought the heatsink had a hole drilled in it, and it doesn't. So the heatsink goes in there, hopefully. Yep. and the transistor goes on it, and there's a hole. So I am not going to attempt to film drilling a hole. I shall go and drill a hole, and we will reconvene then. Okay, so we have now a heatsink with a hole in. We have a screw, a nut, two washers, an insulating washer, a little insulating spacer, whatever they're officially called, and we have some transfer compound. You see that? Chewed by the dog. Thank you, Minnie. However, I believe there's some left in. I haven't got any more if there isn't. So, let us take our transistor off, and the first thing we want to do is solder the heatsink in place. So, to do that, and to put it all in a vase, passes for a dice. I want to turn the iron back on and give it a minute to warm up. In fact, I might turn it up to 411 centigrade. I know solder melts well below that, but that is the temperature in there somewhere. The temperature at the tip is somewhat less. Get rid of that. Best to clean it. Okay, let's go. Come on. Well, that's holding it, so it's going to do for now. I am probably going to find, oh yes, ow, that's where all the heat's gone. I suppose it doesn't help having it in there either. So I'm going to probably find a soldering iron with the bigger bit that can get the heat in more efficiently, and just have another go at these, and we'll just tack them in for now. Oh, there we go. Right, we've got solder on the pad and on the tab. Just going to look at it and say, oh, this is where I find I've got it the wrong way around. So now we want one of these with some heat, transfer compound on. Come on. This is always gacky stuff. Oh, we're still on the... There we go. We'll put some of this lovely stuff on the back of the transistor. Oh, that's enough. That's enough. I need a thin layer. And this is probably the only vaguely static sensitive device on the board, and no, I'm not wearing a wrist strap because my hand is down on the mat, which is my excuse. And I've got another transistor if I blow it up. Oh, come on. Bent the legs so it doesn't. Ah, there we go. There we go. There we go. Oops. I'll turn the iron back down before it burns the bit out any faster than it's burning out already. Right. One washer, one spacer, insulator, whatever it's officially known as, and it's not lined up with a hole. Ummm. There we go. We're on. That was that fell off. A washer on the back. We'll have the nuts on here. Come on. Grab my Allen key. Okay, so sorted it out and took the dog for a long walk as well. So it's somewhat later. These things go through the transistor. I said it won't because I've smashed the hole up, and should we see if we can get that, and into the heatsink to locate the transistor, and I hadn't drilled the hole in the heatsink out big enough, so I forgot to take the transistor out while I was drilling it out, and made a bit of a mess of that. Fortunately I had another one, so here we are finally, the transistor mounted nicely in the heatsink. So all we need to do is solder it. So, forgotten to turn the soldering iron back on. No. Heatsink stuff everywhere. I don't think it'll solder too well. Right. There we go. Mine wasn't quite hot enough. Have I bridged across those? No. That'll do. Just cut the legs off that. Which leaves us with that and, where they've all gone, the pin headers which go down onto the Arduino. So if we put this on first, I have got it a bit wrong here, and it goes over the idents, but never mind. Let's prop that on the solder. Again, we'll just do one. Check it's flat down. It is. Oh well. Get rid of the calipers and solder the rest down. Okie dokie, so that leaves the pin headers. These are long, so so these are the pin headers, and they're nice and long, so I need to cut them. They're nicely, this board is nicely spaced off the Arduino, and the bottom of these doesn't catch on USB socket, etc. So, shall we start soldering some of these on? Mark it then, try and guess. And downwards. In fact, what I might do is mount all these in here and then just drop the board on and solder them, because that way we know they'll all be lined up correctly. Yep, I'm using a black pen on black plastic, and if I line it up exactly right to the lights, I can see where it is, I think. Whoops. Now I'm shooting across stuff I want across the room. It occurs to me I'll maybe using 10, 12, well maybe a bit more with these, but I could actually just put these on that are actually used instead of putting them all on like I'm doing, but at this point it's easier, I reckon, to do this than try and have to go back and work out which ones I actually want. Okay. Two, wasn't it? And that's assuming I actually have enough in total. I might yet have to... Oh, what's going on here? What have I done? I might yet have to resort to borrowing bits off of connectors I'm not using. There we go. Alright. I've ordered plenty enough. Not checking whether that was working in camera. Well, hope I don't need that bit. There we go, so all we have to do is slot this on here. Come on. She's on. Right, so we've got a bunch of pins to solder in. So let's go. Let's hit it. Right, I should have put these on before, put the heatsink on. The best way to do this. Too much solder. I'll have to come back to that. Use this way around so the camera can see it. Things I do for you folks. Done! We just have this one there, which is bridged across. Okay, it's normal other stuff I edit out. So, desolder braid. It's just copper braid impregnated with flux, and the solder, you hope, sticks to this and is wicked off like that. There we go. I don't like solder suckers. You press the button and they jump, so they're not actually sucking the solder from where you want to suck it, and they always get gummed up and the seal goes and the tip goes. So I use desolder braid. Right, so that's it, done. Apart from the RS232 and the memory card, the SD card, which I'm going to put on when the rest of it's working. And there we go. So there it is, it's built. I am going to leave testing for the next video in the battery tester charger series, because this one's gone quite long enough. I thought I'd try something different and a bit of real-time soldering. So if you've enjoyed it, let me know, comment, subscribe if you like the channel, and until next time, it's goodbye from Tripplikit, home of interesting electronics. Goodbye.